derivatives and integrals. We have completed derivatives and integrals. Now we are going to look into differential equations. Both derivatives and integrals are required for solving this differential equations or forming the differential equations. Both the derivatives as well as integrals are required. So if we are thorough with both the derivatives and the integrals, then we will be able to do problems in differential equations. Now let us see what is a differential equation. For a given function g, so there is a given function g, find a function f such that dy by dx is equal to g of x, where y is equal to f of x. So finding a function f for a function g, that is such that dy by dx is equal to g of x. The equation of the form 1 is called differential equation. Equation of, that is dy by dx is equal to g of x, is an example for differential equation. Let us see more detailed what is a differential equation. Now I will write some equations here. You see, x square minus 2x minus 3 is equal to 0. Sin x minus cos x is equal to 0. Sin x minus cos x is equal to 0. You can find in this there is this x is called independent variable. X is called independent variable. In these equations, we are finding only independent variable, or sometimes we may get, you can see, a dependent variable. Y is called dependent variable, x is called independent variable, because y depends on the value of x. Y depends on the value of x. So these equations, they contain independent variable and or dependent variable. So dependent variable can be there or it may not be there, but you see dependent variable is there in the fourth equation, independent variable is also there. These equations are, we call this, name of these equations algebraic equation, this is a trigonometric equation, the fourth one is also trigonometric equation. Like that, what is a differential equation? Let us see. What is a differential equation? Now I will write an equation like this: x into dy by dx plus y is equal to 0. Let me take an equation, consider an equation x into dy by dx plus y is equal to 0. Now, in this equation, apart from the independent variable and dependent variable, there is one more thing is there. What is that? Derivative of the dependent variable with respect to the independent variable. So this equation 5 is called a differential equation. This is called an ordinary differential equation. So how we will define, what is the differentiation between ordinary equations and differential equations? We should have in the differential equation an independent variable, a dependent variable, and the derivative of dependent variable with respect to independent variable. So then the equation will be called as ordinary differential equation. Now I will write the definition for differential equation. You can see an equation involving a dependent variable, an independent variable, an independent variable, comma, a dependent variable. So an equation involving, you can see here an equation involving independent variable, dependent variable, and then the derivative of dependent variable with respect to an independent variable, is called an ordinary differential equation, is called an ordinary differential equation. So is called an ordinary differential equation. Sometimes, so differential equation definition is clear. An independent variable which is x, a dependent variable which is y, and the derivative of the differential dependent variable which is dy by dx. So this is a very important definition for differential equation. Sometimes the derivatives here, the derivative is with respect to only one variable. Sometimes we get derivatives with respect to different variables, one or more variables. Like this, you can see f is the function, the derivative is with respect to x, del. So these things, this notation is taken as del f by del x, del f by del y. They are called partial differential equation, and these are called partial derivatives. If we get partial derivatives in the equation, then we call that as partial differential equation. But in our 12th standard or the second PUC, we have only the subject ordinary differential equation, not a partial differential equation. Now I am giving you in physics or chemistry, you may be coming across this del f by del y, del x, and del f by del y partial derivatives also we will be coming across in science subjects. Differential equations are very important in the science subjects. Now we have defined the differential equation. Once more I will see that what is these 2, 3, 4 equations are equations involving only dependent or independent variables. Okay. The fifth equation involves derivative of the dependent variable along with independent and dependent variable. So that is called a differential equation. Now let us take the next one, order of a differential equation. 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 Let us take order of a differential equation. Now we define the order as order of the differential equation is the highest ordered derivative, order of the highest ordered derivative occurring or involving in the differential equation. So, order is the derivative. You have to look up the derivative. So, you know the derivatives are like this: dy by dx, d square y by dx square, d square d cube y by dx cube, etc. So, these are the derivatives, different ordered derivative. This is a first order derivative, this is a second order derivative, this is a third order derivative. Like that we can go up to nth ordered derivative. We can go up to nth order derivative. So, order of the differential equation is the order of the highest order derivative occurring or involving in the differential equation. So, the order of the highest order derivative involving in the differential, involving or occurring in the differential equation. Differential equation is called order of the differential equation. Order of the differential, order of the highest order derivative involving or occurring in the differential equation is called order of the differential equation. Now, we have defined order of the differential equation. You see, when only dy by dx is there, the equation is called first order derivative and first order differential equation, and this is second order, and this is third order, and like that nth order derivative. Now, let me give some examples for order of derivatives. Now, you see d cube y by dx cube, dy by dx plus sin x is equal to 0. What is the order of this differential equation? Order is the highest ordered derivative is 3. So, highest order derivative occurring in the differential equation. So, order is 3 here. Now, dy by dx whole cube, dy by dx whole square plus y is equal to 0. Now, you can see here, do not mistake, order is only one order derivative is there, that is first order derivative. Therefore, what is the order of this differential equation? 1. 1 is the order of the differential equation. Next, let us see d square y by dx square plus y is equal to 0. Now, this equation contains a second order derivative. So, only one derivative is there, that is second order derivative. So, order is 2. Order of the derivative is 2. Next, we will see the degree of differential equation. Degree of differential equation. Now, let me take a different degree of differential equation. Degree of the differential equation is first, the differential equation should be a polynomial in derivatives. Differential equation must be a polynomial in derivatives. So, equation must be a polynomial in derivatives. Now, I will write some differential equation, then we will find out the degree of the differential equation. D cube y by dx cube plus d square y by dx square whole square plus dy by dx plus y is equal to 0. So, first equation I have written. So, we can see the differential equation. It is a polynomial in derivative. You know polynomial, that is a x power n, like that polynomial where n is a natural number. So, polynomial definition you all know. Next one, let me write. So, two equations, three equations I have written now. So, the second equation is also a polynomial in, that is y2 dash, y dash and y. It is a polynomial in derivative. But the third equation you can see, it is not a polynomial, sine of dy by dx. So, in a polynomial function we don't get other functions, only algebraic functions will be there, x will be there, and there is no sine, cos, log, etc. Even if you get log, so it is not a polynomial, log dy by dx, etc. If you get, it is not a polynomial. So, these first two equations we can get the degree, whereas the third equation we cannot get the degree of the differential equation. Third one we cannot get a degree of the differential equation. Why? Because it is not a polynomial. Now, let us define the degree of the differential equation. The degree of the differential equation is the power of the highest ordered derivative involved in the differential equation, the power of the highest order derivative. So, let us see in the first equation which is the highest order. Highest order is d cube y by dx cube. What is the power of this? You can see power is 1. So, the degree here is 1. Degree of the differential equation is 1. In the second one, let us see second equation. What is the highest order derivative? D square y by dx square, dy by dx whole cube, d plus dy by dx. So, d square y by dx square is the highest order derivative. What is the degree of the differential equation? Power of the highest order derivative involved in the differential equation. Here the highest order is 2. Power of the highest order derivative is also 2. Therefore, the degree becomes 2 for this. Degree of the differential equation is 2. Now, third one, the degree is not defined. Why? It is not a polynomial in the derivative. It is not a polynomial in the derivative. Now, I have defined, I have not written on the board. You can refer the textbooks for the definition of order of the power of the highest order derivative when the equation, differential equation is a polynomial in derivatives is called degree of the differential equation. Okay. We are taking some examples to find order and degree of the differential equation. Order we have defined, that is the highest order derivative. Degree is the power of the highest ordered derivative. Now, I have written the equation dy by dx minus cos x is equal to 1. What is the order? Only one derivative is there, that is first order. First order. What is the degree? So, degree of this derivative is 1. Therefore, the degree power of this derivative is 1. Therefore, degree is also 1. The second one, you can see order is second order is there, first order is there, first order is there. So, second order is the highest order. So, it is 2. Degree of the highest order. The second order has got the power as 1. Therefore, the degree of the highest order derivative. Now, third one, here we have got y3 dash, y2 dash and y dash. So, first order is there, second order is there, third order. So, what is the order of this differential equation? That is 3. But you can see it is degree is not defined. Why degree is not defined? It is not a polynomial. So, this e is e to the power of dy by dx, e to the power of y dash, which is e to the power of, so exponential function. It is not a polynomial function. So, degree is not defined. Now, let us see the problems in exercise 9.1. Exercise 9.1, we will take the first question, the problems. D power 4y by dx power 4 plus sin of y3 dash is equal to 0. So, you can easily find the order. What is the order of this differential equation? Here third order is there, fourth order. So, order is 4. But the degree is not defined. Degree is not defined. Why? Why the degree is not defined? It is not a polynomial in the derivative. So, it is not a polynomial in derivative. So, it is not defined. So, it is not defined. So, we have to be careful when we are calculating the finding the degree of the differential equation. Next question I will write, ds by dt whole to the power of 4 plus ds d square s by dt square is equal to 0. Now, what will be the order of this? Which is the highest order? Second order. What is the degree of the differential equation? The power of the highest order, though this first order has got power 4, only the second order power we should consider for degree, because highest order is second order here. The degree is 1 and the order is 2. Let us see this question. Y dash plus 5y is equal to 0. What is the order here? Only one order is there, first order, and the power of this first order derivative is also 1. So, degree is also 1. Degree is also 1 there. Then the fourth question is d square y by dx square whole square plus cos dy by dx is equal to 0. Now, here you can see we can get the order. Order is here the highest order is there 2, but degree is what is the degree of this differential equation? It is not a polynomial in the derivative. Therefore, degree is not defined. Degree is not defined. Now let us take the next question. D square y by dx square is equal to cos 3x plus sin 3x. So definitely 1 mark question or 2 mark questions, they ask this question in the annual examinations. So very simple, every one of us can score 2 marks here. The order is, you can see the order, what is the order of the derivative? The second order derivative is there, that is the highest order derivative, that is the order is 2. Then degree is, what is the degree of the highest order derivative? Degree is 1. So power of this derivative is 1, therefore degree is 1. Let us go to the next questions. y3 dash whole square, y2 dash whole cube, y dash whole power 4 plus y power 5 is equal to 0. What will be the order for this differential equation? The highest order is third order. Highest order. The degree of the highest order, power of the highest order is 2. It is not 5, 4 or 3. It is only, the degree is the power of the highest order derivative. Highest order derivative, that we have to take it for degree. Now, 7th question is y3 dash plus 2y2 dash plus y dash is equal to 0. Now, you can all by this time you would have learnt it. The order is the third order and the degree is 1. Y dash plus y is equal to e power x. So here order is the first order and degree of the first order is also 1. So highest order is first order there. Now 9th question. y2 dash plus y dash whole square plus 2y is equal to 0. All of you will be able to tell the differential, the order and degree for this. Order is, the highest order is the second order, here y2 dash is there, and then the degree of the y2 dash is 1. So the degree is 1. Now next 10th question. y2 dash plus 2y dash plus sin y is equal to 0. Here also the order is 2. Degree is 1. Now I will write some entrance examination questions, that is multiple options. The degree of the differential equation, the degree of the differential equation. So they have given a differential equation, we have to find its degree. D square y by dx square whole cube, dy by dx whole square sin of dy by dx plus 1 is equal to 0 is A 3, B2, C1, D not defined. Not defined. Now I have written the options. Which option is the correct option for the degree? So degree is the equation is not a polynomial in derivative. So the degree is not defined. So this is the answer there. Now let us take the next question. The order of the differential equation. The order of the differential equation. Order of the differential equation. 2x square d square y by dx square minus 3 dy by dx plus y is equal to 0. Now I will write the options A3, B2, C1, D not defined. Now you can see order is the definition for order of the differential equation is highest ordered derivative. Here the second order derivative d square y by dx square is there. Therefore, answer is B. So, second order derivative. So, this completes the first exercise. Then let us continue with this. Now, we will take what is a general solution or particular solution of a differential equation. General solution. General solution or particular solution of a differential equation. Let me consider some simple equations which is like this. Let us consider x plus 1 is equal to 0. Take this as first equation and we will take another equation which is sin square x minus cos x is also equal to 0. Here we get these two equations, the solutions for these two equations are either a real number or a complex number. When we substitute these values in the unknown variable, here the unknown variable in both the equations is x. So, if we substitute x which is a real number or a imaginary number, complex number, the solution becomes LHS is equal to, equation becomes LHS is equal to RHS. For example, I will tell you x square is equal to minus 1. What is x? X is equal to plus or minus I. So, it is a complex number. Suppose here I will take LHS. LHS is I square plus 1. What is I square? Minus 1 plus 1. So, LHS is equal to RHS. Like that, for the second equation also we can find solution for x, and if we substitute in the x, LHS becomes RHS. So, let us take a different type of equation. Consider d square y by dx square plus y is equal to 0. For the first two equations, the solution was a real number or a complex number. But for the third equation, solution is a function. For this, solution is a function. Let us take that function as pi, which satisfy the equation 3. Equation 3. That is, if you substitute the value of pi, that is, when you substitute unknown is y, when you substitute the function, it becomes LHS is equal to RHS. Now, let us consider an equation of this type pi. Y is equal to pi of x. let me take this y as a into sine of x plus b, where a and b, a, b are arbitrary constants belong to real number. Y is equal to pi of x, let me take it as a sine x plus b. When we substitute this pi of x in the equation 3, the equation is satisfied, that is LHS is equal to RHS. In this equation you can see a and b, two constants, arbitrary constants are there. So these constants are also called, what is these constants called? You can see these constants a, b are called parameters. This y is equal to pi of x is a curve called integral curve. So y is equal to pi of x. So this is a differential equation. If you want to find the solution, we may have to integrate this. Then we can find the value of y. Y we are taking it as pi of x. Pi of x is called integral curve. So it is a curve or the solution curve. You can also write that as solution curve. And I have taken one equation 4, which is y is equal to pi of x a sine of x plus b, where a and b are called parameters. So this equation, that is a solution. The solution pi of x is called general solution of the given differential equation. Now let me take for pi, instead of that, let me take pi 1 of x, which is equal to 2 sine x plus pi by 4, by taking a is equal to 2, b is equal to pi by 4. When we substitute pi 1 of x, in the equation 3, the equation is satisfied. So when we substitute LHS is equal to RHS, when pi 1 of x is substituted in equation 3. So this is also a solution of the given differential equation, but in this the parameter a is fixed 2 and parameter b is also fixed pi by 4. So a particular value for the parameter is given. So this solution is called particular solution. The solution pi 1 of x is called particular solution. So in the differential equation, the solutions are two. One is a general solution and another is a particular solution. So what is a general solution? The solution of the differential equation involving arbitrary constants is called a general solution. What is a particular solution? A particular solution is the solution obtained by giving a particular values for the arbitrary constants is called a particular solution, by giving particular values for the arbitrary constants. Therefore, there will be no arbitrary constants in the particular solution. There will be no arbitrary constants. What is an arbitrary constant? It is a variable constant. So we can vary the value of a and b. A can take 3, b can take pi by 2, etc. Therefore, we can vary that is called arbitrary. Any constant is called arbitrary constant. It is a variable constant. We can consider that as a variable constant. Whereas here 2 is a fixed constant, pi by 4 is also we cannot change. So, they are particular values of A and particular value of B. That is called particular solution. Okay. Next we will see the we will be given a differential equation and its solution. We have to verify, that is we have to prove LHS is equal to RHS, that is the general solution, and a particular solution they would have given, that we have to substitute in the differential the given equation and differentiate it and prove that LHS is equal to RHS. We will see that next. Okay. So, we have just seen the definition for general solution and also the particular solution. Now, we will see problems. A solution is given and we have to verify that the solution in the given differential equation. For that, what we have to do? See, we have been given a function. So, given function is y is equal to e power minus 3x. This function y is there. Now, we have to find dy by dx and d square y by dx square and substitute in the given differential equation and prove that LHS is equal to RHS. So, that is the verification for us. So, the procedure for this is first to take the function, differentiate with respect to x, differentiate with respect to x. We can see differentiation of y is dy by dx. What is the differentiation of e power minus 3x? Minus 3 e power minus 3x. Now, again let us differentiate. Differentiating again with respect to x. Differentiating again with respect to x. Dy by dx, if we differentiate, we get d square y by dx square, and minus 3 is a constant. Again, if we differentiate, minus 3 e power minus 3x, that is 9 into e power minus 3x. So, third equation. Now, let us use 2, 3 and 1 in equation 3 in d square y by dx square plus dy by dx minus 6y is equal to 0. Now, let us take LHS. What is d square y by dx square? 9 into e power minus 3x plus what is dy by dx? That is minus 3 into e power minus 3x. Minus 3 into e power minus 3x. Minus 6y. Minus 6 into what is y? Y is e to the power of. Okay, let me verify. I think this must be plus 6. You take plus 6. Plus 6 into e power minus 3x, which is equal to, okay, minus 6x is correct, okay, that is minus 6, here also minus 6, here also minus 6 minus 3, it is minus 9, here plus 9, so it is equal to 0 RHS. So, what is the procedure for this? Find out dy by d square by dx square, substitute in the given differential equation, prove that LHS is equal to RHS. So, this is the method of verification. The second chapter gives in differential equation verification. You will be given a function and its a differential equation. We have to verify the differential equation using the function. Using the function, we have to, now the given function is y is equal to a cos x plus b sin x. Differentiating with respect to x. Differentiating with respect to x. What is dy by dx? A is a constant, differentiation of cos x is minus sin x. Again, b is a constant, differentiation of sin x is cos x. Now, again differentiating with respect to x, differentiating with respect to x, again differentiate dy by dx, differentiation is d square y by dx square, d square y by dx square minus a into cos x. Here cos x is minus sin x differentiation, minus b sin x. So, this is 3. Now, substituting 2 and 1, 2 and 1 in d square y by dx square plus y is equal to 0. What is d square y by dx? A minus a cos x minus b sin x. This is the LHS, d square y by dx square plus y. Y is a cos x plus b sin x. So, you can see both minus a cos x plus a cos x cancels, minus b sin x plus b sin x cancels. So, we get 0 which is equal to RHS. So, we have proved LHS is equal to RHS for this differential equation using the function. So, this is the answer for that. Now, let us go to the exercise problems. So, exercise 9.2, verify. So, like what we have been given, a function will be given and we have to verify the differential equation. So, y is equal to e power x plus 1. The differential equation here is y2 dash minus y is equal to 0. So, what is the procedure for this? First, we have to differentiate the function. So, differentiating with respect to x, dy by dx is equal to e power x. So, this is the second equation, first equation. Again differentiating with respect to x, d square y by dx square is also equal to e power x. Now, we take the equation y2 dash minus y is equal to 0, substituting y2 dash, that is d square y by dx square, LHS is equal to e power x, and y2 dash minus y, I think y dash, okay, y2 dash minus y dash. Take this as y dash, e power x minus e power x is equal to 0, which is RHS. So, this is how the first problem in your exercise 9.2 comes, that is y is equal to e power x plus 1. Prove that y2 dash minus y is equal to 0. We have to get the first order and second order derivative, substitute in the given differential equation and prove that LHS is equal to RHS. So, next question is second question. You can see they have given the function and its differential equation. We have to verify it. Now, differentiating, keep this as 1, differentiating with respect to x, y dash is equal to 2x plus 2. So, in the given differential equation only y dash is there. So, we can stop it. So, what is here? LHS is equal to y dash minus 2x minus 2. What is y dash? 2x plus 2 minus 2x minus 2 is equal to 0, which is equal to RHS. So, verification is over. This is how we have to verify LHS is equal to RHS. The given function we have to differentiate and substitute that in the differential equation derivatives. We have to substitute in the given differential equation and then say that, prove that LHS is equal to RHS. Y is equal to cos x plus c. Y dash plus sin x is equal to 0. So, we should know the differentiation, we should be thorough for this. So, differentiating with respect to x, y dash is equal to minus sin x. Constant differentiation is 0. Now, LHS is y dash plus sin x. What is y dash? Which is minus sin x plus sin x is equal to 0, which is RHS. So, this is how we have to solve the exercise questions. Y is equal to square root of 1 plus x square. Y dash is equal to xy divided by 1 plus x square. Let us differentiate this. Y is equal to root of 1 plus x square. How will you differentiate this? Differentiating with respect to x, y dash is equal to 1 by 2 square root of 1 plus x square into 2x into 2x. Now, so this can be taken as x by square root of 1 plus x square. Now, we have to take this differential equation LHS. LHS is equal to y dash. Y dash we have calculated as x by root of 1 plus x square. How will you get a y there? What is y? Y is multiplying it with root of 1 plus x square, multiply with root of 1 plus x square. Now, root of 1 plus x square is given function as y. So, the denominator becomes 1 plus x square. So, LHS is equal to RHS. So, there is some small algebraic steps that we have introduced here, because here y is there. So, we have to put root of 1 plus x square. So, divide by root of 1 plus x square, multiply by root of 1 plus x square. So, you will get x into y divided by 1 plus x square. So, this is how we have to prove these questions. Now, fifth question, y is equal to capital A into x. So, here capital A is a constant, and we have to prove the differential equation is x y dash is equal to y. X is of course not equal to 0. Now, differentiating with respect to x, y dash is equal to a into 1, it is a, y dash is equal to a. Now, LHS is equal to x into y dash. What is y dash? X into a. A into x is nothing but y, which is equal to RHS, hence verified. So, we have verified the function and its differential equation. You can see sixth question, y is equal to x into sin x. X y dash is equal to y plus x into square root of x square minus y square. X not equal to 0, x greater than y, x less than minus y. So, let us differentiate this. How to differentiate y x into sin x? We have to use product rule. Use product rule for this. Y dash is equal to x into cos x plus x into cos x plus sin x into 1. So, this is y dash. Now, we have to prove the LHS is equal to RHS. Now, let us take LHS x into y dash. What is y dash here? X into x cos x plus sin x. What is x into x cos x? That is x square cos x, x square cos x plus x sin x, x sin x. Now, we need x into root of x square minus y square. How will you get this? What is cos x? See here, sin x is equal to y by x. See, y is equal to x sin x. Sin x is equal to y by x. What is cos x? What is cos x? Root of 1 minus sin square x. Root of 1 minus sin square x. What is the sin x? We have got square root of 1 minus y square by x square plus x sin x. So, x square into square root of x square minus y square divided by square root of x square in the denominator, we can take it as x, and this is x sin x is y. So, you can cancel this x into square root of x square minus y square plus y. So, this is what is RHS. So, we are proving consistently LHS is equal to RHS by differentiating the given equation and substituting in the LHS, we get the RHS. How we are getting? You see here cos x values we do not know, but x sin x is nothing but y, cos x is 1 root of 1 minus sin square x, sin x is y by x. So, sin square y square by x square 1 minus root y square by x square square root of. So, that will be x square minus y square square root divided by x. So, we get the answer as LHS is equal to RHS. Now, let us go to the next question here. xy is equal to log y plus c. Xy is equal to log y plus c. Y dash is equal to y square by 1 minus xy. Xy not equal to 1. Xy not equal to 1. Now, how to differentiate this? So, it is implicit functions. We know implicit function differentiation. How to differentiate this? Differentiating with respect to x. X into first function into differentiation of the second function, y is y dash plus y into second function into differentiation of first function, which is x, it is 1, is equal to log y differentiation 1 by y into y dash plus 0. So, that is the differentiation here. Now, let us take xy dash minus 1 by y dash is equal to minus y. Now, y dash we will separate this, y dash into x minus 1 by y is equal to minus y. Here y dash into xy minus 1 is equal to minus y. So, this is y dash is equal to, we get minus y square divided by xy minus 1, this can be taken as y square by 1 minus xy. So, here LHS is equal to RHS. So, while differentiating we got that LHS is equal to RHS, y dash is equal to, we have proved y dash is equal to y square by 1 minus xy. So, this is how we have to prove this. So, this question is 7th question. Now, let us see The eighth question. Y minus cos y is equal to x. The differential equation is y sin y plus cos y plus x into y dash is equal to y. Now, differentiating with respect to x, this is y dash minus cos y differentiation is sin y into y dash is equal to x. So, what is y dash? Y dash into 1 plus sin y is equal to x. Y dash is equal to x by 1 plus sin y. Now, we have to substitute this in the differential equation, that we can do it here. LHS is equal to y sin y plus, I can take this as cos y plus x, cos y plus x into, what is x, the y dash? 1 plus sin y. If you simplify it, we should get y sin y, cos y plus x. We can see here cos y plus x we can substitute, that is as y. Cos y plus x is y only. Y dash is equal to y we have to prove. Let us try this. Xy sin y, this I can take it as y itself. So, xy, this we can take it as x. So, x into y divided by 1 plus sin y. Now, we can take this xy we can take out, xy into sin y plus 1, sin y plus 1 divided by 1 plus sin y. This is equal to xy. So, we are getting, instead of y, we are getting here as xy. You can verify this, y dash, y minus cos y is equal to x. So, this is y dash plus sin y into dy by dx, that is y dash. Y dash, if you take it, 1 plus sin y is equal to x, y dash is equal to x by 1 plus sin y. So, this is the method of solving this differential equation. I think we should get in the solution, we should get here as xy we should get, then we will get the correct answers. See, y sin y plus cos y plus x into y dash. So, cos y plus x, I have considered it as y. So, here xy sin y plus x into y. So, divided by 1 plus sin y. So, xy into sin y plus 1 divided by 1 plus sin y. So, this is equal to xy, that is RHS. So, we should get the result. I think there is a small error in the question and given question itself. So, let us correct it. Now, we will go to the next questions. We will go to the 9th question in the exercise, which says that x plus y is equal to tan inverse of y. Differentiate this equation, differentiating with respect to x, differentiation of x is 1, differentiation of y is y dash. What is tan inverse of y? Differentiation 1 plus 1 divided by 1 plus y square into y dash. Now, let us separate y dash here. So, y dash into 1 minus 1 plus y square is equal to minus 1. So, y dash into 1 plus y square minus 1 by 1 plus y square is equal to minus 1. So, here it cancel this, y dash y square is equal to minus of 1 plus y square. So, now let us take the LHS of the equation, the differential equation, y dash y square plus 1. What is y dash y square? We have calculated minus 1 minus y square plus y square plus 1. So, this is equal to 0. So, we have proved that LHS is equal to RHS. So, I have calculated y square y dash after differentiating the given function. Like that we can do the 10th question also. What is the 10th question says, what is y dash here? Differentiating with respect to x. How will you find out dy by dx? Root function 1 by 2 root x, 1 by 2 square root of a square minus x square. Then we have to apply chain rule. A square minus x square, if you differentiate, you get minus 2x. So, on simplification, we get what is dy by dx? X by square root of a square minus y square, or what is root of a square minus x square, which is y, that is the given function. Now, we can take the LHS of the given differential equation, x plus y dy by dx, x plus y into minus x by y, which is equal to x minus x, which is equal to 0. So, that is RHS. That is the verification for the function and its differential equation. Function is given, differential equation we have done this one. Now, you can see some important questions in the entrance examinations. The number of arbitrary constants in the general solution of a differential equation of a 4th order. First order means there will be 1 constant, second order means 2 constants, third order means 3 arbitrary constants will be there, fourth order differential equation 4 arbitrary constants will be there. So, the answer here is D. D is the answer for this question. Number of arbitrary constants, first order it is 1, second order 2, third order 3, and the fourth order 4 arbitrary constants will be there. Now, the number of arbitrary constants in the particular solution, of the differential equation, particular solution there will be no arbitrary constants. We have seen the definition of particular solution, there will be fixed constants, there is no arbitrary constants in the particular solution. So, what is the answer for this question? Answer is D option, which is 0. 0, number of constants, arbitrary constants will be 0. Thank you. This completes the second exercise also. Okay.